for herpes and HPV. And it's logical. Here's why. Men cannot control when they're going to ejaculate. You don't go 10, 9, 8, 7, no. You can't predict exactly when it's going to happen. And if he's withdrawing when he ejaculates, he can shoot around it. And he can leak behind it and get you pregnant and give you HIV. But because it covers mucous membranes better and the cervix, it is better for herpes and HPV. So it's slightly better for herpes and HPV because it covers more area. It's slightly less because you can shoot around it. And then one last thing. We gave it to women who were married, who were doctors. And we came back and women just raved about it. And one of them said, well, several of them said this that really shocked me. They said, we loved it so much, my husband just absolutely said he wanted handfuls of them because he didn't know I was wearing it at all. That's really upsetting if a man doesn't know any more about what's going on down there and she's wearing this huge device that he can't figure it out. No wonder we have such a high divorce rate. But the other bad thing they reported was it makes a noise. We recommend you turn up the stereo. Okay, so any questions about the female condom? Advantages, disadvantages, cost, anything? Okay, let's move to the Mentor. And Mentor was made originally by 3M. What are they famous for? Post-its and?
Tape.
Cellophane tape. And what do Post-its and cellophane tape have in common? Glue. That's what it is. It's a condom with glue. Many of the people's complaints was that condoms slip off during use. And so 3M designed a condom. By the way, it comes in a 1-inch square box like this. And inside you see this gigantic rubber thing. And most people think that's the condom. It's not. It's an applicator. You just take this out and put it over the end of the penis. Take the applicator off and then roll down the condom. It's a latex condom with glue. Water-soluble glue. So what it does is it glues the latex condom without any sort of, you don't have to get out and get a roller ball of glue and put it on there. Yeah, get your fingers all gooey. It's already made up. This is just an applicator, but we actually had people try to use this as some sort of French tickler. I mean, they put it on and they didn't pull the applicator off, they just started having sex. You know, there's no feeling to something with rubber that thick. None whatsoever. I don't even know. I guess, yeah, for a woman it's probably exciting, but for a guy. So anyway, here's the advantages and disadvantages. One, it won't slip. That's a big advantage. And what's the disadvantages? It's expensive. It's $3 to $5. It's also latex, so you have to use a water-soluble lubricant. To it. And next, let's see. It has the same defects of other latex condoms, but here's the biggest disadvantage. When men are done, we're done. We don't want to hug, we don't want to kiss. We want the remote, and we want you to leave us alone. And when a man is done, he reaches down and he grabs the condom and he jerks it off and throws it in the garbage. You cannot jerk this off. If you jerk it off, you jerk your thing off. If you roll it on, you gotta roll it off. If you grab it, you'll be just led around because it will not come off. Now it doesn't leave any residue around behind, but you have to roll it on and roll it off. So That's the mentor. Okay, anyone have any questions about condoms and proper use and all that? Yeah.
I was going to shoot two things. One, polyurethane condoms are the ones that are like the really thin ones.
Oh, yeah.
So, and they're considered an alternative pure fluid to latex.
That's right, because of people that are latex allergic. You can use any lubricant with it?
Yeah, I just checked that.
Okay, good.
But the other thing I was going to say is that when I worked, used to work at Planned Parenthood when I was
How do you spell urethane?
It's URET.
URETHANE.
And the advice we gave is that if it's somewhere that can melt a candy bar, that is not a great place to store a condom. And
Oh
after
yeah,
7
like
years,
wine.
it's completely
Don't
violent.
freeze it and don't let it get too
It
hot.
has people who, turn 14, start carrying around a condom, and 6 years later, it's been in their wallet or in their glove box.
Yes, we call them wallet condoms. And, oh, I forgot to tell you that condoms in America come in sizes. They don't write small, medium, and large because nobody would buy the small. And if you go to the pharmacy, you will find that all the large ones are always sold out because Americans have gigantic egos. So men buy the gigantic ones. So let's talk about, if it says ultra here, or it says ultra sensitive, it means small. If it doesn't say anything about ultra nothing, then it's medium. And if it says magnum or XXX, it's large. And this has to do with length and circumference. So remember, there are 3 sizes, but they don't put small because nobody would buy them.
But that also has to do with what it's made of.
Right, it
They
does.
advertise polyurethane.
The key word is, I don't think they ever use ultra, do they? I hope
I don't
not.
know, I haven't.
That's the key word.
How many inches?
We're not going there.
I will say, during like demonstrations to middle schoolers and high schoolers, like take a regular latex condom and pull it up at my elbow and stretch my hand out just to demonstrate the point that every guy who has a complex that he's so big he can't possibly wear a condom.
Is making it up.
Yeah.
Yes. All right, so now we're going to get to testing, and we are going a little longer, so be patient. We're talking about testing. Remember, if you're looking for the body's response to an infection, that's called indirect, and you're looking for antibodies. If you're looking for the actual causative agent, the bacteria or the virus or the fungi, that's a direct test or an antigen. Remember, anything that causes the immune system to respond is an antigen test. And those are direct tests. And anything that is indirect, or is the body's response to an antigen, is an antibody test or an indirect test. Now, it's kind of funny, the indirect tests are incredibly accurate, incredibly sensitive, incredibly cheap, because antibodies are made in huge amounts once they're made, but they're all delayed, 60 to 90 days. So they are what we get for $1. The direct tests are always either really bad, if they're cheap, or really expensive, because you're actually looking for something 100,000 times smaller than a bacteria. So remember, the direct tests are expensive or bad. And bad meaning they're not accurate. And then the indirect tests are sensitive and accurate and wonderful and cheap and everything good you can think of, but they have one huge fault: time delay. After infection takes 30 to 90 days, we say on an average 60. The indirect tests that we use in this country are all like the ELISA, the fluorescent body, antibody, and the rapid test. All the rapid tests are indirect. All of these are antibody tests. And then all of these over here are antigens. So we're going to talk about them a little bit and how they work. And then there's the third kind that we talked about recently. And that's the Red Cross sandwich assay. Now, everybody look at me. If you have an antigen, a virus of this shape, and your body makes an antibody to it, what's the first thing the antibody does when it comes across that virus? It sticks. That's called an antigen-antibody complex. And when you're early in infection, every antibody that is made sticks to a virus. Is it available for a test to detect then? No, it's bound already. So remember, if you're running an antibody test and you're early in infection, every antibody that's made by your body will stick to the virus and not be available for the test to measure. So what the Red Cross did, and it's absolutely brilliant, probably hired somebody smart to do it. But anyway, what they did was they take someone's blood and they add an enzyme to it that breaks apart antigen-antibody complexes, providing a huge excess of antibody for the ELISA to detect. So they add an enzyme to the blood to break antibody-antigen complexes, and then they do a cheap and crappy antigen test as well. So they're doing two. They're doing an antibody and an antigen. The antigen test is not that great, but if you have a huge amount of it, it would show up. But the big thing they're doing is adding that enzyme to break apart antigen-antibody complexes when you're newly infected and providing a lot of excess antibody for the test to detect. And it can get it down to 10 to 14 days. The window can be shortened from 90 days to 10. So 10 to 14 days, we have had them detect as low as 10. They really recommend that, 2 weeks is the best, 14 days. So this is why it's called a sandwich. So one of the test questions says, the sandwich assay for HIV is a turkey sandwich. It's not. It's a blood test where they use an enzyme to separate antigen-antibody complexes and then do both an ELISA and an antigen test. So let's look at the ELISA. Remember, what is the ELISA? A plastic plate, and you coat it with whatever you want to test for. The agent of disease coats a plastic plate. Then you add patient blood serum and horseradish peroxidase, and when an antibody and an antigen stick together, in the presence of horseradish peroxidase, it oxidizes and turns color. And we always run a row of negatives and a row of positives, known positives. So, now remember that this test, no test is perfect. So you're going to get a test that is, the top 10% of the negatives are reported to the laboratory as positive. Why? We don't want to make the mistake of transfusing blood that's about to turn positive. On the borderline, you don't want any of the borderlines to be transfused. You want to test them. Again, yeah?
Explain what you mean by top 2%.
Okay, so remember every test has a number. They're all based on a number. They're running up. They're actually sending a light wave through this plate to see how much light is blocked. And so if 100% of the light passes through, then that's going to be the negatives. And so we sit down here and we say if 85% makes it positive. So what do we do with that area between the known negative and the first positive? Call that the high positives. So remember, it's a daily stepping stone of how much antibodies you're going to make before you cross into the positive zone. So if that's increasing every day, then you're going to get somebody that are in the top of the negatives. Remember, most of the blood you test is going to be very positive or very negative. But there are people that are about to be positive. Those are the people that are have been infected maybe 70 days ago, and they're making more and more antibodies. So this test was designed to protect the nation's blood supply. It was not designed to find out if you're positive. It was designed for one reason and one reason only. HIV was in the blood supply, and we don't want to make a mistake by accidentally transfusing blood that might be high negative, that might be positive. So that's why it over-reports. Now, does it report it to a person? No. It reports it to the laboratory as a high negative. And all high negatives and positives are repeated. So if you get a positive test, remember, you've had 2 ELISAs. If it was positive, it's repeated. If it's borderline, it's repeated. If it's positive or negative after being borderline, then it goes to the next level of testing. Anyone confused? Everybody know how it's run? The ELISA test? Okay, so these are all the rapid tests. Some are approved in this country, some are not. All I have to tell you is they're all antibody tests. So they're all rapid. Even though they are rapid, they're still antibody tests. You don't have to know anything except that the rapid test, the quick test, the ones you find out in 20 minutes or 10 minutes, are all antibody-based. All right, so what happens in the state of California if you come back borderline or positive twice? You go, only in the state of California, you go to fluorescent antibody testing next. Every other state, you go to the Western blot next. In California, you go to the fluorescent antibody. Why? The state of California has its own FDA called the Bureau of Biologics. And the Bureau of Biologics is set up for human experimentation and testing, laboratory testing. And the state of California said we want to regulate our own within our own borders, and we will, and the federal government, after going to the Supreme Court, let them do it so long as their regulations were as strong or stronger than the FDA in Washington. Now, why do people want to use the Bureau of Biologics? Because it's only 500 guys in Sacramento versus 16,000 bureaucrats in Washington that'll hold up your application for months and months and months. And since the regulations are tighter, they're safer, and people trust the Bureau of Biologics better than the FDA. So, here's what a fluorescent antibody test is. You put HIV-infected white blood cells, just a drop of them, on each well in a fluorescent slide. Now, this is a regular microscope slide with a layer of plastic over it with just holes about the size of a pencil eraser. So you put 1 drop of white blood cells infected with HIV in each one of these wells, and then you let it air dry, and then you add patient blood serum and fluorescent dye. Now the fluorescent dye will stick if the antibody sticks to an antigen. So if the antibody and antigen stick together in the presence of this dye, it cannot be washed off. So after you put the white blood cells on there and let them dry, then you put the patient serum on, let it dry, then add the fluorescent dye, then you wash it off, and all the dye will wash off if the antigen didn't stick to the antibody. If it did, then when you put it under UV light, the fluorescent dye will glow. And you can see it glows in the shape of white blood cells, little round white blood cells. And a negative would look like this, and a positive would look like this. I made this slide from a guy who walked in off the street in 1984, said his boyfriend died of HIV and he thinks he was infected, and there was no blood test. So we did a fluorescent antibody, and he was positive. So, when we run these, we always run 2 wells as positive controls, 2 wells as negative controls, and then each patient gets run twice. So we run 4 patients and 2 controls on every slide. If the person is positive or confusing, they go to the next level of testing. This takes 25 cents. ELISA is $1. So you have $2 spent on your ELISAs and you have 25 cents on the fluorescent antibody. So you realize that the state of California gets rid of their false positives for 25 cents. While the rest of the states and territories go to Western Blot, it costs $75. Okay, so remember, if you're positive or negative on ELISA, you go to another one. If you're positive or negative on the second one, you go to fluorescent antibody. If you're positive or confusing on fluorescent antibody, you go to the next step, which is Western Blot. And if any of these, they're negative, it stops. So here's a Western Blot, and on the Western Blot, we take a piece of paper and put it in a plexiglass container. And we fill that container with saline. Then we add whole HIV. That's what I used to do, is grow up whole HIV and freeze it for the Western Blot. Then we add detergent. Detergent breaks HIV into its individual proteins. Then you put it on a positive and negative charge overnight on a rocker. The individual proteins migrate according to size. The heavy ones don't move much, the light ones run. And they spread out on this piece of paper. And the next day when you come in, it's still a white sheet of paper. Nothing. You can't tell anything has happened. So then we add patient blood serum and horseradish peroxidase. If antibodies exist in the patient's serum, they will stick to the individual proteins that cause their formation. So everyone, remember all those numbers? Each one of those was a protein. Each one of them makes an antibody. If you have blood serum that has an antibody to anything on this strip, it will stick there, and horseradish peroxidase will turn it black. So we always run a multiple band control positive, somebody that's a high positive, and the second strip is a known negative, and then we run the patients. And if the patients have a band at the marker that is an HIV marker, then they are considered positive for that protein of HIV. So if you have one band, you're set indeterminate in the window, come back for further testing. If you have 2 bands, indeterminate in the window, come back for further testing in 3 to 6 months. If you have 3 bands, you're HIV antibody positive, Western Blot confirmed with 3 bands. Why don't we say 1 band? Because when Jane Getchell, next question, who designed the Western Blot, Jane Getchell, my boss, why'd she name it Western Blot? Because there was already a Northern Blot and a Southern Blot. She thought it'd be nice to call it a Western Blot. I thought that was the stupidest explanation. Jane, everyone in the world's going to be using your test, and you just named it Western Blot? And she said, well, it would be arrogant to call it a Getchell Blot. So anyway, remember that when they first had it, to test it in huge numbers of people, they needed huge numbers of people. So they passed the law saying that everybody in the military would be tested once a year. That's how they found out if this test would work. And when they did that, they had a whole bunch of Navy pilots in San Diego show up with a 1 band of P24. And they went down and investigated, and that's impossible. None of them were IV drug users, none of them were multiple sexual partners, saw prostitutes, were gay, or anything. There's no way these guys could be positive. And then they had a bunch of women in the military that had a P55. and nothing in their history showed any sort of risk behavior. So they did what you do when you have a bad problem with your computer. What's the first thing you're supposed to do? Nope. Reboot. So they came back 2 months later and tested again, and the P24 went away, the P55 and the women went away. So then they went back and looked at their medical history in the last year and found all the guys that had a Asian flu, and all the women were pregnant, early in pregnancy. So we found that 2 of these bands can have different diseases. Pregnancy is a disease. And that's transient, a transient band. So now that's why we have 3 bands required to be HIV antibody positive, Western blot confirmed. Okay, the direct antigen test is the bad direct test. And all you do is you take that, remember how we did the ELISA? In ELISA, you took the plate and you coated it with the antigen. In this case, we buy antibodies from a person that's positive with a very high P24 core antigen. And we coat the plate with somebody's antibodies. Then we add blood plasma from a patient because plasma has more viral particles than serum. And then we add horseradish peroxidase, and we hope there is enough viral particles in the plasma to show this up as some sort of color. And it hardly ever works. The only time it works, remember the viral load? A person at day 14 would be P24 positive, and then not until 15 years later. It takes a huge viral load for this test to be positive. Why do we have it to begin with? It was only for tissue culture to see when to harvest your virus. That was what it was designed for, but it's only 25 cents. So we started using it for, I know you're going to be shocked, hysteria. You see, when people get needle stuck or get bitten, you can't tell them. No one has ever gotten it from being bitten. A policeman doesn't understand that. He says, "Ah, I've been bitten." And then you say you've got to wait 90 days, and he goes, "Ah, I got a gun!" You know? So you want to give them something that will tell them an answer that will make them happy and enable them to handle the weight. So we use it for needle sticks and for bites to calm people's nerves. When I got a needle stick, I immediately ripped open the package, looked at the code for the experiment, looked it up, and it said 10 million concentrated HIV. Now, I didn't know if that Pasteur pipette had the 10 million concentrated HIV. All I knew was that experiment was working with 10 million HIV. And what did I do? I got hysterical. I went looking around for an axe to cut my arm off with, and I couldn't find one, and then I thought, well, it'd been too long, it circulated. Then I tried to get non-alcohol 9, I rubbed it in the cut, and I realized it probably had circulated. And then I went to the window of the 7th floor of the virology building and tried to decide if I jumped, would I really be dead when I hit the bottom? Because if I'd really be dead, I'd do it. But if I'd just be mangled and then die of AIDS, I didn't want to do that. And so I finally called up the doctor on call. There's always one at CDC, there's 16 buildings. They have a doctor on call all the time. And I called him up and he goes, "Excuse me, sir, I can't understand you. Stop sobbing." And I said, I think I stabbed myself with 10 million concentrated. I don't even remember how much it was, but a hysterical amount. And I go down there and he tells me, he goes to this old song and dance. There is nothing we can do. There is an antibody test. It takes 90 days. Oh, but guess what? We do have a P24. If you got a huge dose, it'll be positive. And we'll know today. And I can run it in 30 minutes. Now, I knew that was a shift test. He knew it was a shift test. I wanted him to run it. He ran it. He came came back, congratulations, it's negative. I knew it'd be negative. He knew it'd be negative. It's a crappy test. But it enabled me to handle the little story, well, you know, if you come back in 30 days and it's negative, you have a 66% chance that it's correct. And if you come back at 90 days and it's negative, you have a 98% chance it's correct. If you come back in 6 months and it's negative, you have a 99.9% chance that it's really negative. And I did all those things, and I guess that pipette was used on saline instead of the virus because I wasn't infected. But you know what? The P24 helped. When else do we use it? Well, if you're in an upper volta and you don't have any electricity to test somebody, you can do a rapid test on a person's finger and find out they're positive. You hand them 3 months of medications and take a sample of their blood for a P24 and run it. Come back 3 months later and take a sample of their blood and run a P24, and you can find out if their viral load has come down. So it's good for hysteria, and when you have nothing else in a third world country where you have no electricity, you can see if your medication worked, at least a little. All right, so the viral load test, remember there are 2 of them. There's the viral load 1 and the viral load 2. Viral load 1 is $500 and it can get down to 20,000 copies per mil. So that's big. And the viral load 2 is $1,500. It's the newest test. And it can detect down to 2,000 copies per milliliter of blood. But my test question on this one is 0 really 0? When this test prints out 0, is it 0? On PCR1, it's 19,999 is 0. Anywhere from 0 to 19,999, because the lowest the test can read is 20,000 copies. So 20K equals 0. So is 0 really 0? No. And is on the PCR2, is 0 0? No. 1999. So remember, none of these tests is 0 really 0. That's a test question. What does 0 really mean 0? Is it real 0, or is it just the best the test can measure? It's just the best the test can measure. All right, and remember the PCR test is not licensed by the FDA to test whether or not you're positive. It can test at day 7, but you have to fork up the $1,400, $1,500. So remember that. Okay, let's talk about what is genotyping. It costs $5,000. You may not have this one. It costs $5,000, and it is a way to take a sample of your HIV and see what drugs really work on it. And it's called HIV genotyping. And it's extremely expensive, $5,000 just to find out what drugs to give you. So when is it appropriately used? 1, on babies. Babies are going to have to be taking these drugs for 60 years. You want to target the drugs so they don't wear out all of their abilities. So another one, the best people to get the genotype is a baby. Because they're going to be having to taking these drugs throughout their childhood and so forth. And if you start them off on something random and it doesn't work, and then you lose that usage. So remember, number 1 is you want to do babies and children. You want to do patients who have failed other drug treatments. In other words, they gave them this and it quit working on them. It mutated. And then if you have the money, you want to give it to people that have just turned positive, so you give them the best drugs early in their treatment. Remember, if you hit it hard early, they think theoretically you can wipe it out. So it's 3 groups of people should get genotyping. The ones that can afford it and want to get the best drugs first and live the longest, babies who are going to have to take it the longest, and people who have failed other treatments and have nothing left to go on, and you don't want to do a trial and error and put them through years and years of trying this out and see if it works, or that out and see if it works. In the future, I'm sure we will get the price down and everybody will be genotyped. But right now, insurance won't pay for it unless you failed other treatment or your baby. All right, so that takes us to drugs. Drugs. And you don't have to know brand names, but you do have to know which ones happened in what order and what they do. So, we're going to start off. Everybody listening? Because I want to get through this before 10. All right. You want to go back and pick up everything, so we got it all in one. All right, so here we go. The very first drug that came out was a thymine nucleoside analog. Thymine nucleoside analog. It was AZT, a fake thymine. Now, what does it work best on? When you get infected with HIV, it infects your lymphocytes. And there are 2 kinds of lymphocytes. Those that know they have been infected by a foreign agent and are triggered to rapidly divide to fight it. That's bad. If it's infected and it's rapidly dividing, it's actually increasing the virus. Those are called activated T cells. And that's what works best. AZT works best on activated T cells. Thymine nucleoside analogs, test question, work best on activated T cells. What are activated T cells? Infected T cells that know they're infected are rapidly dividing, thinking they're going to fight it. The next kind of drug that came out was non-thymine nucleoside analogs. Things other than thymine. And they work better on resting T cells. They've been infected, but they don't know they've been infected, so they're not rapidly dividing. So non-thymine nucleoside analogs work better on resting T cells. All right, the third drug that came out was NNRTIs. And those are called, wow. For some reason, I have the wrong order here. Okay, this should be 4. There it is. Here it is listed as number 2 over here. Non-nucleoside reverse transcriptase inhibitors, NNRTIs for short. Remember, HIV needs this enzyme that converts viral RNA to viral DNA. So what NNRTIs do is they encircle reverse transcriptase and prevent it from functioning. So these first 3 drugs came out. What did it do to people? Well, AZT had a bad reputation because there's one genotype of person that gets it, it will kill them. The drug will actually kill people that have a very rare genotype. So that was bad. Also, the companies that made it made outrageous profits of $1,500 a month on a drug that we tested for free for them at the CDC. So they didn't even pay for the clinical testing. We did it, and yet they made huge profits. So that was bad. But in number 1, number 2, and number 3, all it did is maintain people. They still declined a little bit, but not as rapidly. They didn't get any better. So this was a big help. Yes, they didn't decline as fast, but they didn't get any better with non-nucleoside or non-thymine nucleoside inhibitors, analogs, or thymine or NNRTIs. And then the drug that changed the world. And the drug that changed the world is this one, the protease inhibitors. Let me just give you an example of what happened. Had a friend that was HIV positive. He was on the first 3, kept getting worse and worse and worse, and then I got a call. Come to the HIV treatment hospital at Kaiser on Sunset because they're giving him last rites tonight. He was 220 pounds, and when I went to see him, he was 7 pounds. He had wasted to nothing. He didn't even know anyone was there. Everybody was there. The priest gave him last rites. We all said goodbye. And 6 months later, I got a birthday card from him saying, come to my birthday party. And I was shocked. I went to visit him, and he was getting better every day. In fact, 2 years after that, he became Mr. Weightlifting California, Mr. California Weightlifting. And he walks around now looking better than anyone in this room because of the protease inhibitors. He got an emergency release early before they were approved. And they got him on, and it changed the world. Protease inhibitors changed everything in HIV care. Why? If you go to the garage tonight and a rapist comes at you with a baseball bat and he comes directly at you, you can defend yourself half-assed. And if even 2 of them come at you, you can go back and forth. But if they come at you at 3 different directions, your ass is grass, isn't it? Same thing with this. If you attack the virus in 3 genetic directions, it cannot orient its mutational ability in any one direction. As a result, it is severely defeated. So what they do now is they give a non-thymine nucleoside analog, a NNRTI, and a protease inhibitor. And that became known as the 3-drug cocktail, and it changed the world and led to the other ones, which is HARRT. Now, the next drug that came out was the one that's back here, the fusion inhibitor. It is almost as bad as interferon. It's horribly expensive, requires weekly injections, and everybody that takes it feels like hell. It blocks the attachment of HIV. Oh, I forgot to tell you what protease inhibitors do. Remember the steps in viral replication? Adsorption, penetration, synthesis, maturation, and release. Protease inhibitors prevent, remember this, what does this virus do? It takes over the cell, tells the cell to make protein capsid. Once it makes the capsid, it puts the DNA or RNA inside. So when they make the capsid, they make it as a long protein, and then protease cuts it into individual strands that form the capsid. So a protease inhibitor prevents assembly and release. It prevents the cutting of the protein of the capsid into the correct lengths. So that's what it did. Fusion inhibitors prevent HIV from attaching to the attachment sites of host cells. It blocks it. And the newest fusion inhibitor that just came out this year are called CCR5 antagonists, and they don't have the side effects of Fusion, the first one. So they are blocking any virus that gets out is blocked from infecting new cells with the CCR5. Okay, the last group is integrase inhibitors. And integrase inhibitors were approved last year. And remember the steps of infection. You add here, you inject, you convert viral RNA to viral DNA. Then the viral DNA integrates into your chromosome. Integrase inhibitors block integration. And they're the newest, and they're great. Now, what else is there? They're working on maturation inhibitors, and they just finished the CCR5. So there's lots of drugs in the pipeline, but we have lots of options, and you saw all these brand names. These are different ones. If you get one and it quits working, they just switch you to another one. And they monitor it with viral load tests. Now, here's some of the questions on the exam about this, and that is, what are the problems with HARRT? Number one is side effects. It causes tremendously high tremendously high cholesterol and what's that other one goes with it? Triglycerides. Many people die of heart attacks from the protease inhibitor side effects. And there is a really ugly side effect called lipodystrophy. They get these huge bubbles the size of ping pong balls of fat directly under the skin, usually on the forehead or on the arm, and sometimes on the back of their neck. It looks like a tumor, but they're about the size of ping pong balls, and they are lipodystrophy, abnormal globs of fat. They will also get, you'll see guys that are out there, they're all muscular and weightlifters, and yet they will have an abdomen that looks like, somebody that doesn't exercise. That is also lipodystrophy. It is lipids and fat buildup in the abdomen. The final thing besides all these lipid problems is in the drugs are mitochondrial toxicity. So you have to look for rashes that appear and see if they are allergic. You have to look for mitochondrial toxicity, and you constantly have to monitor the triglycerides and cholesterol and give them Lipitor and other things like that. It used to be a problem with administration regimes. Administration regimes have now been solved. Administration regimes is that these drugs, many of them have to be taken with a quart of water. Some can't be taken with food. Some have to be taken 2 hours after eating. Some have to be taken with milk. Some cannot be taken with milk products. The rules are outrageous. And for years and years, it was a big problem because there is one huge problem. We've already talked about side effects with lipodystrophy, cholesterol, triglycerides, and mitochondrial toxicity. But the biggest problem of all is one dose, and it quits working. It mutates if you miss one dose. So if you've seen people with HIV, they are carrying around these little timer medicine things. They ding all day long, and they're taking their pills because they miss one dose. It doesn't work. Now, with the Clinton initiative, the Clinton Foundation, they have actually devised pills that are one-day pills. Now, what's the problem? Remember, if you reinfect yourself with someone else by unprotected sex and you get the strain they have that's immune to the pills you're taking, your treatment could go crazy. So there are still problems with this. All right, so the Nobel Prize is there. We have a very short 2 little videos. We are going to go to the real time that you're supposed to be going home tonight. I'm sorry. That's going to be the 10:15, but you will get everything. So, what are you going to see? You're going to see a very short video on treatment, and then a very short video on the very first vaccine. And I want to go over one thing really quick, and that is testing. When you're testing a new drug, there is phase 1, phase 2, phase 3, and phase 4. Phase 1 is called toxicity testing, and you do it in people in a coma. Remember, you can test the drug in a hospital, or you can test the drug on people anywhere, on animals. But until you give it to the first person, you don't know if it kills people. So what they normally do is they give it to people that are terminal or in a coma. That's called toxicity testing, and it's usually less than 10. In the drug AIDSVAX, which was made from the outer covering envelope of the AIDS vaccine, remember they took the genes from the virus that code for this envelope, and they put it in Asian hamster ovary cells. Instead of making estrogen, those Asian hamster ovary cells made GP120, envelope protein. Then they made that into a vaccine, and they gave it to people, and The first people they gave it to was cloistered nuns in San Francisco that volunteered their bodies to see if it was toxic. Then the phase 2 group, remember this is terminally ill usually, or coma. In this case, it was cloistered nuns. Phase 2 is to see if there is any measurable physiological change. And that's usually 300. And in the case of the AIDSVAX vaccine, they gave it to IV drug users and prostitutes that were negative. Not a good group to give it to, do you think? Even if they're HIV negative, are they going to stop prostituting? No. And are they going to stop shooting up? Probably not. And remember, no drug, no vaccine works with one injection. So they had to give it to them over a year, every 2 months. And several of these people got infected during the study. So it was rejected for further government funding because they picked the wrong group of people to test phase 2. Anyone tell me the wrong groups? What are the 2 wrong groups? IV drug users and prostitutes. Now, why is that a wrong group? Because before they get all the boosters, they could have done these bad behaviors and got infected, and several people did. Then phase 3, remember, is 5,000 people to see if it really is effective in the general population, and they actually took them 3 years to get 5,000 or more. They finally got somewhere around 7,500. 2/3 of the people got the vaccine, 1/3 got the fake placebo. And then after 3 years, they ran it for another 2 years. And when they did the results, no significant difference in the group that got the vaccine and the group that got the placebo. So what did they prove by doing AIDSVAX? They proved that, one, the government said you couldn't do a study without increasing people's unsafe behavior. They thought they would be in a vaccine study, so they'd whore around more. That was not true. The unsafe behavior declined tremendously. The other thing was that they proved was GP120 doesn't work for antibodies. And the final thing they learned was, for the first time in all of American history, in all science, 98% of all the people that were in the study stayed in 6 years. Remember, they usually lose almost half. And yet 98% of the people remained in the study. That's how important it was to the people that were in it. They were HIV negative getting this vaccine. What else? Here's the good news. They tried it again in Thailand, and it failed again in Thailand. They kind of, what's the word, spiked it. When they were asked why it didn't work, they said, well, it may have worked in Asians, but it didn't work in whites and Hispanics. But it might have worked a little bit in blacks and Asians. And then they did an Asian study, and it didn't work. So they went back and they super analyzed their results, and there were only like 5 people out of 7,000 that were Asian or black that got any response. So that was kind of not very moral event. But here's the last thing. There was another failed drug called a T-cell vaccine, and it was with canary pox. They took a canary pox and they knocked out the part that made it pox and put in an HIV gene inside it, and it failed. But here's the interesting thing. They took these people that had no response on the AIDSVAX and gave them the canary pox virus on top. One's a T-cell, one's an antibody. This is a T-cell vaccine. This is an antibody vaccine. They put one of the HIV proteins in. I don't remember which one. The one that most stimulates T-cell response. here's what happened. 25% of the Thai people that were vaccinated were protected. Oops, not 25, sorry, 22. 22% is better than ever before, and it was combined 2 failed vaccines. So that's the only AIDS vaccine that showed anything, is combining 2 failed ones. Okay, we're gonna watch this real quick, and then we're done.
5,000 volunteers.
Sorry. I'm gonna speed it past.
This is ABC7 Los Angeles. Now, Mark.
Get right to this stuff that you want to see, so. Come on.
This video is called AIDSVAX.
Yes. It's actually a report from 60 Minutes. I'll try to speed through the.
Because AIDS, it's an
Dr. Hicks, real quick, you have 4 phases on here. What's phase number 4?
Phase number 4 is long-term treatment. Since it didn't get past phase 3, it didn't go to 4. So that's 100,000 people for 10 years, is phase 4. Okay, there it is.
What's the second 5,000? You said 5,000.
That's how many people were in the original AIDSVAX study.
Smallpox.
5,000.
When we track
They
down
thought
AIDS and
5,000,
kill
they
it,
got 7,500, but it just.
like you did with smallpox, that's the plan.
The vaccine was given to 4 chimpanzees. The chimps were then exposed to massive doses of the AIDS virus, and it worked. Today, the vaccinated chimps have been HIV-free for 10 years. The liquid in this bottle could either be nothing or it could change the world. It's called GP120, and it might be the vaccine that prevents AIDS. If GP120 succeeds, it will be because one man, Don Francis, wouldn't let it die. GP120 has powerful enemies. Funding for it has been eliminated again and again. But because of Francis, GP120 is now being injected into nearly 8,000 volunteers in the first full trial of a potential AIDS vaccine. Francis is one of the world's leading scientists in the field of infectious diseases, and now he's betting his career and reputation that GP120 is the answer to AIDS.
There are no human viruses that kill 100% of the people that they infect. HIV is extremely close to that 100%.
Worst thing you'd ever see.
Certainly the worst thing I've ever seen by now.
Don Francis has seen millions of lives wiped out by epidemics and millions of others saved by vaccines. He's an epidemiologist living in the hills outside San Francisco. For Francis, epidemiology is science and shoe leather. He can tell you stopping a plague takes a vaccine, courage, and force of will. It's all about endurance. Perhaps his greatest success was 25 years ago. Francis led a team from the Federal Centers for Disease Control to Bangladesh and ended a centuries-old scourge, one patient at a time.
You cornered smallpox.
We cornered smallpox, pushed it off the face of the earth.
How'd you do it?
If you can corner that last person and insulate them from everybody else, that is, put a wall of vaccinated people around them, there's no place for the virus to go, and it dies off.
A year later, in the Horn of Africa, Francis landed in the middle of another fast-moving epidemic, one that killed within hours both the victims and the doctors who treated them.
And when a man is done, he reaches down and he grabs the condom and he jerks it off and throws it in the garbage. You cannot jerk this off. If you jerk it off, you jerk your thing off. If you roll it on, you gotta roll it off. If you grab it, you'll be just led around. Because it will not come off. Now, it doesn't leave any residue around behind, but you have to roll it on and roll it off. So that's the mentor. Okay, anyone have any questions about condoms and proper use and all that? Yeah.
I was gonna shoot two things. One, polyurethane condoms are the ones that are like the really thin ones.
Oh, yeah.
So, and they're considered alternative pure fluid to latex.
That's right, because of people that are latex allergic.
And you can use latex lubricant.
You can use any lubricant with it?
Yeah, I can check that.
Okay,
I
good.
verify that. But the other thing I was gonna say is that when I worked, used to work at Planned Parenthood when I was.
How do you spell urethane?
It's URETHANE. And the advice we gave is that if it's somewhere that can melt a candy bar, that is not a great place to store a condom. And
Oh,
after
yeah,
7
like
years, it's
wine.
completely
Don't
violent.
freeze it and don't let it get too
It
hot.
has people who, turn 14, start carrying around a condom, and 6 years later, it's been in their wallet or in their glove box.
Yes, we call them wallet condoms. And, oh, I forgot to tell you that condoms in America come in sizes. They don't write small, medium, and large because nobody would buy the small. And if you go to the pharmacy, you will find that all the large ones are always sold out because Americans have gigantic egos. So men buy the gigantic ones. So let's talk about, if it says ultra here, or it says ultra sensitive, more than a bacteria. So remember, the direct tests are expensive or bad. And bad meaning they're not accurate. And then the indirect tests are sensitive and accurate and wonderful and cheap and everything good you can think of, but they have one huge fault: time delay. After infection takes 30 to 90 days, we say on an average 60. The indirect tests that we use in this country are all like the ELISA, the fluorescent body, antibody, and the rapid test. All the rapid tests are indirect. All of these are antibody tests. And then all of these over here are antigens. So we're going to talk about them a little bit and how they work. And then there's the third kind that we talked about recently. And that's the Red Cross sandwich assay. Now, everybody look at me. If you have an antigen, a virus of this shape, and your body makes an antibody to it, what's the first thing the antibody does when it comes across that virus? It sticks. That's called an antigen-antibody complex. And when you're early in infection, every antibody that is made sticks to a virus. Is it available for a test to detect then? No, it's bound already. So remember, if you're running an antibody test and you're early in infection, every antibody that's made by your body will stick to the virus and not be available for the test to measure. So what the Red Cross did, and it's absolutely brilliant, probably hired somebody smart to do it. But anyway, what they did was they take someone's blood and they add an enzyme to it that breaks apart antigen-antibody complexes with glue. Many of the people's complaints was that condoms slip off during use. And so 3M designed a condom. By the way, it comes in a 1-inch square box like this. And inside you see this gigantic rubber thing. And most people think that's the condom. It's not. It's an applicator. You just take this out and put it over the end of the penis. Take the applicator off and then roll down the condom. It's a latex condom with glue, water-soluble glue. So what it does is it glues the latex condom without any sort of, you don't have to get out and get a roller ball of glue and put it on there. Yeah, get your fingers all gooey. It's already made up. This is just an applicator, but we actually had people try to use this as some sort of French tickler. I mean, they put it on and they didn't pull the applicator off, they just started having sex. You know, there's no feeling to something with rubber that thick. None whatsoever. I don't even
Well, for the
know.
other one.
I guess, yeah, for a woman it's probably exciting, but for the guy. So anyway, here's the advantages and disadvantages. One, it won't slip. That's a big advantage. And what's the disadvantages? It's expensive. It's $3 to $5. It's also latex, so you have to use a water-soluble lubricant. To it. And next, let's see. It has the same defects of other latex condoms, you know, but here's the biggest disadvantage. When men are done, we're done. We don't want to hug, we don't want to kiss. We want the remote, and we want you to leave us alone. For herpes and HPV. And it's logical. Here's why. Men cannot control when they're going to ejaculate. You don't go 10, 9, 8, 7, no. You can't predict exactly when it's going to happen. And if he's withdrawing, when he ejaculates, he can shoot around it. And he can leak behind it and get you pregnant and give you HIV. But because it covers mucous membranes better and the cervix, it is better for herpes and HPV. So it's slightly better for herpes and HPV because it covers more area. It's slightly less because you can shoot around it. And then one last thing. We gave it to women who were married, who were doctors. And we came back and women just raved about it. And one of them said, well, several of them said this that really shocked me. They said, we loved it so much, my husband just absolutely said he wanted handfuls of them because he didn't know I was wearing it at all. That's really upsetting if a man doesn't know any more about what's going on down there and she's wearing this huge device that he can't figure it out. No wonder we have such a high divorce rate. But the other bad thing they reported was it makes a noise. We recommend you turn off the stereo. Okay, so any questions about the female condom? Advantages, disadvantages, cost, anything? Okay, let's move to the Mentor. And Mentor was made originally by 3M. What are they famous for? Post-its and
Tape.
cellophane tape. And what do Post-its and cellophane tape have in common? Glue. That's what it is. It's a condom. It means small. If it doesn't say anything about ultra nothing, then it's medium. And if it says magnum or XXX, it's large. And this has to do with length and circumference. So remember, there are 3 sizes, but they don't put small because nobody would buy them.
But that also has to do with what it's made of.
Right, it
They
does.
advertise polyurethane. all
The
the
key word is, I don't think they ever use ultra, do they? I hope
I don't
not.
know, I haven't.
That's the
figured
key
it
word.
out.
How many inches?
We're not going there.
I will say, during like demonstrations to middle schoolers and high schoolers, I can take a regular latex condom and pull it up at my elbow and stretch my hand out just to demonstrate the point that every guy who has a complex that he's so big he can't possibly wear a condom.
Is making it up.
Yeah.
Yes. All right, so now we're gonna get to testing, and we are going a little longer, so be patient. We're talking about testing. Remember, if you're looking for the body's response to an infection, that's called indirect, and you're looking for antibodies. If you're looking for the actual causative agent, the bacteria or the virus or the fungi, that's a direct test or an antigen. Remember, anything that causes the immune system to respond is an antigen test. And those are direct tests. And anything that is indirect, or is the body's response to an antigen, is an antibody test or an indirect test. Now, it's kind of funny, the indirect tests are incredibly accurate, incredibly sensitive, incredibly cheap, because antibodies are made in huge amounts once they're made, but they're all delayed, 60 to 90 days. So they are what we get for $1. The direct tests are always either really bad, if they're cheap, or really expensive, because you're actually looking for something 100,000 times smaller.